Electrical safety is paramount in any environment where electricity is present. Understanding the fundamental concepts and adhering to established practices are crucial for preventing accidents, injuries, and fatalities. Let's delve into some key areas of electrical safety. Firstly, understanding the nature of electricity itself is essential. Electricity is the flow of electrons through a conductor. This flow is driven by a voltage difference, measured in volts, between 2 points. The rate of electron flow is called current, measured in amps. Resistance, measured in ohms, opposes the flow of current. These three quantities are related by Ohm's law, which states that voltage equals current times resistance. A solid grasp of these basic electrical principles is fundamental to understanding electrical safety. Secondly, it's important to recognize the hazards associated with electricity. Electrical shock occurs when a person becomes part of an electrical circuit, allowing current to flow through their body. The severity of the shock depends on several factors, including the amount of current, the path of the current through the body, and the duration of the shock. Even small amounts of current can be fatal. Arc flash is another serious electrical hazard. It is a type of electrical explosion that occurs when a fault causes a high-energy discharge through the air. Arc flashes can generate intense heat, pressure waves, and blinding light, causing severe burns, hearing loss, and other injuries. Electrical explosions can also result from the ignition of flammable gases or vapors by electrical sparks. Thirdly, let's talk about electrical codes and standards. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. The NEC provides detailed requirements for various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. Compliance with the NEC is essential for ensuring electrical safety. Other relevant standards include those developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Fourthly, grounding and bonding are critical for electrical safety. Grounding provides a low-impedance path for fault current to flow back to the source, allowing the overcurrent protective device, such as the circuit breaker or fuse, to trip and clear the fault. Bonding connects all metal parts of an electrical system together, creating an equipotential plane that minimizes the risk of electric shock. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Fifthly, overcurrent protection is another important aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. These devices protect wiring and equipment from overheating and damage, and they also help to prevent electrical fires. Circuit breakers are resettable devices that trip when an overcurrent condition is detected, while fuses are one-time devices that melt and open the circuit when an overcurrent condition occurs. The selection and installation of overcurrent protective devices must be done in accordance with the NEC. Sixthly, let's discuss safe work practices. Before working on any electrical equipment, it is essential to de-energize the circuit and verify that it is de-energized using a voltage tester. Lockout/tagout procedures should be followed to prevent accidental re-energization of the circuit. Workers should wear appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing. It is also important to be aware of the potential hazards in the work environment, such as overhead power lines and confined spaces. Seventhly, consider arc flash protection. Arc flash is a dangerous phenomenon that can cause severe burns and other injuries. Arc flash protection involves the use of PPE that is designed to withstand the intense heat and energy of an arc flash. Arc-rated clothing, face shields, and gloves are essential for protecting workers from arc flash hazards. It is also important to conduct arc flash hazard assessments to determine the potential arc flash incident energy levels at different locations in the electrical system. This information is used to select the appropriate PPE and to establish safe working distances. Eighthly, let's focus on electrical safety training. Proper training is essential for all workers who work on or near electrical equipment. Training should cover topics such as basic electrical principles, electrical hazards, safe work practices, grounding and bonding, overcurrent protection, and arc flash protection. Workers should also be trained in the use of PPE and the lockout/tagout procedures. Regular refresher training is important to ensure that workers stay up to date on the latest safety practices. Ninthly, let's discuss electrical inspections and maintenance. Regular electrical inspections are essential for identifying potential hazards and ensuring that electrical systems are in good working order. Inspections should be conducted by qualified electrical inspectors who are familiar with the NEC and other relevant standards. Maintenance is also important for preventing electrical problems. This includes tasks such as tightening connections, replacing worn or damaged components, and testing electrical equipment. Tenthly, ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electric shock. GFCIs are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit. They are commonly used in bathrooms, kitchens, and other areas where there is a risk of water contact. GFCIs should be tested regularly to ensure that they are functioning properly. 11thly, arc fault circuit interrupters, or AFSIs, are devices that protect against electrical fires. AFSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. They are commonly used in bedrooms and other areas where there is a high risk of fire. AFSIs should be tested regularly to ensure that they are functioning properly. 12thly, surge protection protects electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, and other events. Surge protectors are designed to divert excess voltage away from electronic equipment, protecting it from damage. Surge protection is especially important for sensitive electronic equipment such as computers, televisions, and home theater systems. 13thly, portable generators can provide power during outages, but they must be used safely. Generators should be operated outdoors in a well-ventilated area to prevent carbon monoxide poisoning. Generators should also be properly grounded to prevent electric shock. It is important to follow the manufacturer's instructions for operating and maintaining portable generators. 14thly, extension cords should be used properly to avoid electrical hazards. Extension cords should be sized appropriately for the load they are carrying. They should not be overloaded or run under rugs or furniture, where they can overheat and cause a fire. Extension cords should be inspected regularly for damage and replaced if necessary. 15thly, power strips provide multiple outlets from a single outlet. They should be used properly to avoid overloading the circuit. Power strips should be equipped with surge protection to protect electronic equipment from voltage surges. Power strips should not be daisy-chained together, as this can overload the circuit. 16thly, working with electricity can be dangerous, but by following safe practices and taking precautions, the risks can be minimized. Always to energize circuits before working on them and use appropriate PPE. Be aware of the potential hazards in the work environment and follow lockout/tagout procedures. Regular electrical inspections and maintenance are essential for ensuring electrical safety. 17thly, static electricity can be a nuisance, but it can also be a hazard in certain situations. Static electricity can ignite flammable gases or vapors, causing an explosion. It can also damage sensitive electronic equipment. To minimize the risk of static electricity, use grounding straps and anti-static mats when working with electronic equipment. 18thly, lightning protection systems protect buildings from damage caused by lightning strikes. Lightning protection systems consist of lightning rods, conductors, and grounding electrodes. The lightning rods intercept lightning strikes and provide a path for the current to flow safely to ground. Lightning protection systems should be installed and maintained by qualified professionals. 19thly, underwater electrical safety is crucial in areas such as swimming pools and hot tubs. Ground fault circuit interrupters, or GFCIs, are required for all electrical circuits near water. Electrical equipment should be properly grounded and bonded to prevent electric shock. Swimming pools and hot tubs should be inspected regularly for electrical hazards. 20thly, in industrial settings, electrical safety is of paramount importance due to the high voltage and current levels involved. Workers must be properly trained on electrical safety procedures and must wear appropriate PPE. Electrical equipment must be regularly inspected and maintained. Lockout/tagout procedures must be strictly followed to prevent accidental re-energization of circuits. Arc flash hazard assessments must be conducted to determine the potential arc flash incident energy levels and to select the appropriate PPE. 21stly, electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and damaged electrical equipment. If an electrical fire occurs, the first step is to disconnect the power supply. Use a fire extinguisher that is rated for electrical fires. Do not use water to extinguish an electrical fire, as water is a conductor of electricity and can increase the risk of electric shock. 22ndly, the electromagnetic fields, or EMFs, produced by electrical equipment have been a subject of concern for some people. Studies have not shown any conclusive evidence that EMF cause health problems. However, some people may choose to limit their exposure to EMF by keeping a distance from electrical equipment. 23rdly, batteries are a common source of power for portable devices. Batteries can be dangerous if they are mishandled. Do not short-circuit batteries, as this can cause them to overheat and explode. Dispose of batteries properly. Do not throw them in the trash. 24thly, solar panels generate electricity from sunlight. Solar panels must be installed and maintained by qualified professionals. Solar panels produce direct current, or DC, electricity, which must be converted to alternating current, or AC, electricity by an inverter before it can be used to power appliances. 25thly, wind turbines generate electricity from wind. Wind turbines must be installed and maintained by qualified professionals. Wind turbines can be dangerous if they are not properly maintained. 26thly, electric vehicles are becoming increasingly popular. Electric vehicles are powered by batteries. Electric vehicles must be charged using special charging equipment. Electric vehicle charging stations must be installed and maintained by qualified professionals. 27thly, home automation systems control various electrical devices in the home, such as lighting, thermostats, and appliances. Home automation systems must be installed and maintained by qualified professionals. Home automation systems can be controlled remotely using a smartphone or tablet. 28thly, smart meters measure electricity consumption and transmit the data to the utility company. Smart meters can help consumers to save energy by providing them with detailed information about their electricity usage. Smart meters must be installed and maintained by the utility company. 29thly, electrical safety is an ongoing process. It is important to stay up to date on the latest electrical codes and standards. Regular training and inspections are essential for ensuring electrical safety. By following safe practices and taking precautions, the risk of electrical hazards can be minimized. 30thly, consider the electrical safety in healthcare facilities, which is critical due to the presence of sensitive medical equipment and patients with compromised health. Special electrical systems are required to ensure uninterrupted power supply to critical equipment. Regular testing and maintenance of electrical systems are essential. Staff must be trained on electrical safety procedures. In conclusion, electrical safety is a critical aspect of our lives. By understanding the principles of electricity, recognizing the hazards, and following safe work practices, we can minimize the risk of electrical accidents and injuries.